Hello guys, my name is Vidhansh and today we are going to be talking about gigantic neighborhoods. The guess the spatial objects in the solar system. There are many spatial objects. First of all, we'll be talking about the black hole, neutron star, white hole, quasar and black hole star. These are very fascinating spatial objects. First, we have to talk about the black hole. The black hole is a very dense point in space and time which can attract anything, even light. Even the mighty light cannot escape from the black hole, and it has an extremely dense gravity. The laws of physics don't abide by it, and it is very hard to handle because of its very strong gravitational pull and nature. So there's a singularity at its center. So this singularity is the reason why the black hole is so powerful. It can eat almost anything and is created when a star collapses in on itself, and the gravity is so strong that it fuses even neutrons and creates a black hole. These black holes, if you come in, you cannot come out, and they warp space-time in itself. Scientists believe that it may also be a time-traveling machine or a wormhole. It is very powerful. So, now that we have covered black holes, because we don't know much about black holes, but we do know that if you go to a small black hole, it would eat you instantly. But if you go to a big black hole, it will take you time, about 10 seconds more. But if you go in a big black hole, you will just feel spaghettification. Okay, I'm just over exaggerating or under exaggerating because it will stretch you so much that you could cover the earth 1,000 times. That's just too much. But let's move on to the neutron star. The neutron star is basically when a star collapses, but its core still remains. If this happens, then as the picture shown here, it will turn into a black hole, or it will turn into a neutron star like this. So actually at the outside of the neutron star, its gravity is so strong that it fuses neutrons and protons and electrons to form neutrons. Now these neutrons, as you go, it becomes a neutron sandwich. Not to eat though, because one spoon of a neutron star, even on the outside, is almost 1,000 times denser than the sun. That's huge. I don't know if you would even be able to pick up spoon. Even in space, it is the heaviest object in space. And if you got it to Earth, it would literally pull Earth instead of Earth pulling it. But if you got something stronger, like the entire neutron star itself, it would just stick. And that's why there are magnetars. Magnetars are a very magnetized polar form of the neutron stars and have a lot of magnetic field. We have a magnetic field inside us too. And neutron stars have a magnetic field so strong they can tug on it very strongly. So strongly that if you went near to a neutron star, it would rip you apart just like a black hole would. That is so painful. And so, how do they not attract anything else? Because they're so far away from any spatial object like a black hole or something that it would be impossible for it to have anything come near it. The Earth would be ripped apart into shreds if it came near a neutron star because of the magnetic field. The sun they would two literally merge. That's a lot. And they spin real fast, about at 75% the speed of light. That's huge. So let's just move on to, well, white holes. White holes are also very dense but lose their matter pretty quickly because instead of pulling objects, they don't like matter. They don't like matter. They just yeet it out. Who cares about matter? Who cares about matter? I mean, the white holes literally hate matter, and that may be the reason why it's ejecting matter. It is able to destroy planets, stars, and anything except black holes, and it may be also have the power to rip apart a neutron star. But not in front of a black hole. The black hole would just eat it up, and it would keep throwing matter at it. That's the only way it can defeat a black hole. And either it would overfeed the black hole and make it burst, or it would overspin the black hole and make it rip. But that would take a huge amount of matter, maybe even more than the entire universe itself. But we're not here to talk about that. Then you will find that not only do black holes exist, white holes also exist. And this is pretty dangerous for anything that can be easily ripped apart by matter just yeeting matter at it. It would be pretty dangerous for Earth. Well, what's the next thing? Guessed it right. It's quasars. Now here we come into the hypothetical realm, which is, this is pretty weird, but let's get out of the hypothetical realm and into some button realm. Okay, just press the subscribe button and the like button below, and I will be pretty happy. So let's move on to quasars. Quasars are objects with a lot of mass, like black holes. There are many types of black holes, but quasars are the first. Now, if we go back to black holes, there are three types. One is stellar black holes, which are pretty small, don't have a lot of solar mass. They have about 1,000 solar masses of mass and don't have a lot of power. But supermassive black holes like Sagittarius A star at the center of our Milky Way, that's a lot. That's like 1,000 into a stellar black hole, and they have a lot of mass, about 1 billion solar masses. That's too much. But stupendously large black holes? Weird name, I know, but they're huge, bigger than whole galaxies. They have the power to disrupt even other stellar black holes, because if you multiply like by speculation or estimation, if you multiply a stellar black hole by 1,000,000, that would be a stupendously large black hole. It is huge. Okay, now quasars emit quasi-pulses of radiation. They emit a lot of radiation, have the power to destroy space and time itself, and even create and modify other universes. But they can't, because if there's a quasar, they're already dead. And at that time, the universe was more powerful than quasars itself. But now, as the universe is expanding, it's like an inflating balloon that's going to pop any single moment. Or it will go like this, or 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 this. And there's a theory that universes go from inflating, small, inflate, small, inflate, small, like this. There's a theory, or the universe, what happens? Big Bang, mega Big Bang. That's one of the theories of the universe. Well, more about that later. We will talk about the quasar. These quasars are actually overfed black holes that come from black hole stars. These are very powerful quasi-radiation stars or black holes that can easily destroy anything. And They come from stupendously large stars. When a black hole star is a star with a black hole as its core. When a black hole star is born, it's so huge that it literally its core collapses into a black hole, and this black hole is constantly fed, and then it turns into a quasar with 10,000 billion solar masses, which is about a quadrillion solar masses, which is huge. That's like a quadrillion times a thousand quadrillion times larger than the sun itself. And the sun is so heavy, if you did the math, that would be a lot of Earths fitting into one quasar. Okay, so here a black hole star is born when its core transforms into a black hole. Okay, now it is eaten up, but it has a short lifespan of 700 million years, which is pretty small for any star because it should survive for a few billion years before dying out. But, well, the universe has its changes. Everything changes, and now stars like our sun will be going on and on for billions of years. This is the nature of the universe. The universe is fascinating, and science, it rocks, doesn't it? Well, I don't want a black hole under my feet, so I probably end this video. Okay.